Hello, welcome. Let's try to solve another Leetcode problem. 2204, distance to cycle in undirected graph. Let's first try to understand the problem. So we are given an undirected graph. The node is starting from 0 to n-1. And we want to return an integer array answer of size n, where answer I is the minimum distance between the ith node and any node in the cycle. Yeah, let me just explain the example 1. We have 7 nodes, and those are the edges, and we have the output. So for example, the first one, node 0. Yeah, so for node 0, the distance to the cycle, it is just from node 0 to node 1, it is 1. And for 1, 2, 3, and 4, it should always be 0, because it is inside the cycle itself. And for node 5, the distance is 1, because 5 to 2 is 1. And for node 6, the distance is 2. But how can we solve the problem? If you solve some problem like the cycle with some edges, so this is a pattern. So normally I'm gonna try to solve it by topological sort with a cycle tag. After using the topological sort, I can do something like this. Let me use another color. Yeah, I can disconnect these edges and these edges and all these edges connected to the cycle. So after that, it will be something like that. I will left a cycle. Yeah, after doing the topological sort, I will have a cycle like this. So the next step is how can I check the cycle? For example, if I can check inside of the cycle, there's a node 1, 2, 3, and 4. What I'm gonna do, I'm gonna use a multi-source BFS because I can put node 1, 2, 3, and 4 inside my BFS. Inside my BFS visited set and inside my BFS queue. And then I'm gonna start from the multi-source 1, 2, 3, 4. So for example, 1, I'm gonna start using BFS to 0. So the distance for this 0 becomes 1. And then for 2, the distance to 5. So the distance is 1, and then the BFS to 6, the distance becomes 2. Now the problem becomes really easy. So the first step, we're gonna build a topological sort structure. We're gonna disconnect. Yeah, let me try to use another color. Yeah, I'm gonna try to disconnect all those edges. I need to find this cycle. After finding this cycle, I'm gonna use the BFS starting from all those nodes. So it is a multi-source BFS to find the distance. So the distance for 1, 2, 3, 4, it will be 0 by itself. But for others, I will use BFS to record the result, like 1, 2, and this is 1. So this will be the final solution for this part. Yeah. But for the topological sort, this is an undirected graph. We should know about the integrity should be 1. We're gonna starting from the integrity 1 because this is undirected, bidirectionally connected graph. Yeah. So we're gonna starting from the integrity 1. We're gonna check. After all, if the integrity is 2, it means those nodes will become a cycle. Yeah. Now let's just start coding. I'm gonna use the first example to explain it. Yeah. Let's prepare an integrity. It would be 0 times n. Also, I need a graph. It would be an adjacency list. Now I'm going to build the graph and integrate. So for UV in edges, so first of all, I'm gonna build the graph. Yeah, and similarly, GV should append U. Now I'm going to build the integrate. So the integrate, similarly, it's gonna be the same because this is undirected. I'm gonna build from both sides. Yeah, so integrate U should plus equal to 1, and integrate V should plus equal to 1. Now I need to prepare the queue because I'm going to start the BFS. It would be I for ID enumerate the integrate. So if this D equal to 1, yeah. Let me just print out what is this code looks like. Yeah, I'm gonna return an empty array. I just wanted to check what is this Q looks like. Yeah, because I'm gonna use this Q for the BFS, for the topological sort. I just wanted to make sure everything should be right. As you can see, this is 0 and this is 6, so I'm gonna start in from 0 and 6. Now let's continue. I'm going to build the BFS. So while this Q, I'm gonna pop it out. So yeah, node would be equal to Q dot pop left. I'm gonna check the neighbors. So for neighbor in G with the node, yeah, so the in degree with the neighbor should -1 because I'm executing the topological sort. The in degree should -1. I have a if check. So if this in degree neighbor equals to 1, yeah, it means I can continue. So I can put it inside of the queue, put the neighbor inside of the queue. Yeah. Now I'm going to check what is the in degree looks like, because currently this queue will be empty. But I need to check what is the in degree looks like. Is it like yeah, as my expected? So for neighbor in G node, so here is something wrong. Let me check. Neighbor is not defined. Oh, this is a for, not if. Now let's check what is the neighbor looks like. As you can see, 1, 2, 3, 4, and this is 1, 2, 3, 4, and this is as I expected, because I wanted to, yeah, let those cycle always becomes 2, because this is a undirected graph. So the degree for each of the node inside of the cycle should be 2. As you can see from here, it is always 2. It means 1, 2, 3, 4 becomes a cycle. Now let's just continue. It means the cycle is right. The third step is gonna start the BFS. We just need to build the BFS to solve the problem. This is gonna be easier, yeah. So for the BFS, I'm gonna prepare a result. It should be 0 times n, because finally I'm gonna return this result. And I need to prepare a weighted set. Let me prepare this weighted set. It would be a set, so inside it should be I for IV in, yeah, still enumerate. Yeah, basically I need to copy this. Let me just copy it here. Yeah, so it will be like this. So I for I d in enumerate in degree. So if this d equals to 2, yeah, and similarly I need to prepare the q. It will be the same. Yeah. So this Q, I just updated with a new Q. I just set it as a Q. The Q, let me make it, yes, I just set it as a Q because there's no difference, because this one has already been calculated. Yeah. So I will design a new Q. It's gonna be Q, and inside this degree should be equal to 2, because I want to put all the nodes inside of the cycle. And here I will put I with a 0, because I'm going to check the distance from the cycle to other nodes. So I'm so the starting point will be 0. Now I'm gonna execute the multi-source BFS. So while Q, I'm gonna pop out the node, and depth would be equal to Q dot pop left. So here will be exactly like before. I just needed to copy the code basically. So I don't need to copy it because the structure is a little bit different. So yeah, in order to avoid making mistakes, I will type it for myself. So for neighbor in G node, if neighbor not in visited, visited will add the neighbor. Yeah, I just need to yeah, check the multi-source BFS. So this is node and depth, and the neighbor inside. If neighbor not inside, visited should add, and Q should append with this neighbor, and depth plus 1. And what about the result? So for example, if I'm gonna start from this node 1, it will go to 0. Yeah. So if neighbor not inside, I put it inside. But I can record the neighbor from here. So the neighbor would be result with this neighbor should be equal to depth plus 1. So from here, I've already recorded the neighbor. Finally, I just need to return the result. Yeah, so this is the entire code. Hopefully, I should not make any mistakes. Let me just check. As you can see, it works. Now, let me just delete the print and submit it to check if it can pass all the testing cases. Yeah, as you can see, it's 90%. It passed all the testing cases and it's pretty fast. So this is not a hard problem. The hard part is maybe we didn't know about this kind of a template. The template is just like it's a topological sort plus a cycle problem. If it is like that, normally we're going to execute the topological sort. We're going to disconnect all those nodes which is not inside of the cycle. And the second step, we're going to start from the cycle and we're going to execute the multi-source BFS to find all the distance of the nodes. Finally, we just need to return the result. As the number of nodes is 10 to the power of 5, let's analyze the time complexity. So up to the topological part, the time complexity is E plus V. Let me check the number of edges. Yeah, so the number of edges is also n. This is according to the question. Yeah, it is also n. So the time complexity is just O(n) because the number of edges is equal to the number of vertices. So the time complexity is O(n). Thank you for watching. See you next time.